Today we'll see application of integral. So there is very important application of integral to find out the areas of the curve. So I'll discuss with you this today. Now few figures like you know already, the area of a triangle, area of a circle, how to find out these things, area of a square, area of trapezium. So all these things you know already. But what if you'll get some different kind of figure? Like what about this figure? So you can see here you have a curved line. So like simply you have a curve like this, and in the coordinate axis, let's say you have to find out the area of this part only, that is given the curve as well. So what if you have to find out the area of this part? So does it looks like something these things? No. Okay, so in that case we can use integrations to find out these areas. We can use integration. Now let's say we have a curve like this and we need to find the area of this shaded part. So now what we will do here, we are going to take a strip. So in integration what we usually do, we will take the area of the small part and then we will integrate it, so we will get the area of the whole. Okay, so like I have just taken a strip here. Let's say it is dx. Why it is dx? Because here we have this axis is x-axis. I've taken the small part of it, so that's why it is dx. And let's say you have this curve, that is y equals to fx, and then so this is the equation of this curve, and now we have to find out the area of this curve from this A to B. So A and B are the extreme points. So now you have to find out the area of this part. So for doing this, if you want to find out the area of this strip, so what will be the area of the strip? So that area will be y into dx, because this part is y and this is dx. So here the area of this part will be y dx. But when we will integrate, so this is the area of the strip only, but when we will integrate this one from A to B, we will get the area of the whole shaded part. Okay, so area of the strip is only y dx, but when we will integrate it with the from the limits A to B, it will give you the area of whole shaded part. So like this you can do it. Sometimes you can get some other kind of curves also, like this is another curve. Now here you can see we have taken the another strip. So we have taken the strip here right now. This is the strip. Now we need to find the area of this curve. So the curve is something like this. So in that case you cannot follow something like this. So in that case we have taken this horizontal strip. So in this case you can see this area is dy, this part, this side is dy, and here this is whole x. So area of the strip will be how much? It will be x dy, and area of the full, this is the area of the strip only. And then now area of full shaded part will be given by integration from, and now you can see the limits will be start from where? See, this point is C and this point is D. So the area will be x dy, but from the value C to D. So this will be the area of this part. Sometimes you can get a curve like this as well. So here you can see the curve is negative, like here this is your coordinate axis and the curve is somewhere here. Okay, so in that case again you need to find out the area. So here you can see again this will be dx only, and here this part is y. So the area will be y dx only, but the only difference is when you will give the limits, it's from A to B, the area will become negative, it will come negative. So in that case, when your curve is below the x-axis, in that case your area you will take it as, you will take the positive value only. So in that case you will take the mod of whatever area you will get. So this thing you have to consider in while solving the questions, because area can't be negative, so you need to take the positive value of this. Now this is another case when you can get something like this also. Like as you can see in the figure, the curve is first the curve is below the x-axis, then it is above the x-axis. So in that case, here you can see x coordinate is a. At this point the x coordinate is b. It is given here x equals to b, either here x equals to a. Now let's say here this point is c. So in this case, how we are going to find the area? So you can see we have divided it. You can divide it in two parts. So this one will be the first part. So first you'll find out the area of this part. So here you can see this will be dx, and this we can write that as y dx. Now here the only change will be the value. So a to c y dx. Now as I told, this is below the x-axis, so this area we will take as mod. Okay, so we will take the positive value only. Then we will add the second part. So this is this part. Now we will add this part. So in this part, the area of this will be again same. Here this is dx, so this part is dx, and then again we will write it as y dx, but the only difference is the limit. So here now the limits will be from 0 to c to b. So here the limits will be only c to b. So like this you will solve when you will get two curves. One is in the below the line and one is above the line. So these things you have to see in your while solving the questions. So this chapter is very important, and there are only few formulas that you have to use here. So this formula generally you are going to see in the exercise. So here you have to know this formula. So this is integration of root of a square minus x square is given by x by 2 root over a square minus x square plus a square by 2 sine inverse x by a plus c. So this is the formula that you are going to use in this chapter. So let's see it with the example how to find the area of a curve. So here the question is find the area enclosed by the circle, and the equation of the circle is given x square plus y square equals to a square. So here if you see this equation, you can see that the center is 0 0, okay, and the radius is a. So if you draw it in axis or in axis, you will get this figure. So here you can see this point is a0, and here this point is 0a. Now I have just taken this strip that is dx here. So now to find the area of this, you can see we will find out the area of this blue part, and then we can multiply it with 4 times. So we will get the full area. So here we can write area is equal to 4 times of, here you can see it is y dx, and the limits will be from 0 to a, here 0 to a. Now from where we will get this y? We will get this y from this equation. So as you can see, the equation is x square plus y square equals to a square. So from here you will get y square equals to a square minus x square. Then you can give the root. So your area will be 4 times 0 to a root of a square minus x square dx. And as I told, we know the formula. So we will use the formula here. So here the area will be x by 2 root of a square minus x square plus a square by 2 sine inverse x by a. Okay, this we have here, and then we can give the limits, that is 0 to a. Now simply put the values here, so you will get the area, and you have a 4 also here. So it is 4, then x is a, so this first term will become 0, and the second term will be a square by 2 sine inverse x by a will give you 1 sine inverse 1. Then minus this term will become 0, another one will also become 0, so you will get this thing only. Then it is 4, a square by 2 will come as it is, and into sine inverse 1 is pi by 2. So overall you will get pi a square, and you know this area of the circle is also pi into radius square. And always remember to write square units. So this is the way how to find out the area.